everyone. So in this video, our topic is on set theory. So let us start. So actually, you will see that logic and set theory are very closely related. So set theory. So let us define what is set. So set is a collection of objects or what we call elements. And for us to indicate that a particular element is element of a set, we use this small letter epsilon or small Greek letter epsilon. So you can read this as A is an element of A or A is a member of A. And for you to denote that a particular element or a particular object is not a member of a particular set, you can use this small Greek letter epsilon with a slash. So you can read this as A is not an element of A. And we have here set A is equal to the following sets, or you can also read this as A contains the following elements. So we have A contains the following elements, A sub 1, A sub 2, up to A sub n. And then always remember that order in elements is meaningless. So it doesn't matter kung, for example, meron tayong set A is equal to, or set A contains 1, 2, 3, or set A contains 2, 3, 1, or set A contains 3, 2, 1. So wala tayong pakialam dun sa arrangement or dun sa order ng mga elements doon sa loob ng set kasi it is meaningless. So they are just the same, mga nabanggit kong sets kanina. And then always remember that it does not matter how often the same elements is listed. So kahit na tatlong beses na nilista si 1, it is considered 1 lang din. So set A and B are equal if and only if they contain exactly the same elements. So we have here examples. So we have set A contains 9, 2, 7, and negative 3. And we have set B that contains 7, 9, negative 3, and 2. So they are equal since they have exactly the same elements. So it doesn't matter kahit nandito sa set B is nagkabaliktad yung arrangement ng mga elements. Kasi in sets, wala tayong pakialam sa arrangements. Okay, ng ating mga elements. And then we have here dog, cat, horse, and we have set B that contains cat, horse, squirrel, and dog. So they are not equal. So as you can see naman, doon sa ating set B, merong nadagdag na squirrel which is not an element ng set A. And for the third example, we have set A is, that contains dog, cat, and horse. And we have set B that contains cat, horse, dog, and dog. So remember, kahit na dalawang beses na sinulat or nag-appear si dog doon sa loob ng set, it is considered one na dog pa rin yun. So they are equals. Kasi both set A and B contains the following dog, cat, and horse. So examples of sets. So meron tayong tinatawag na mga standard sets. So these are sets na usually na ginagamit natin sa mathematics. Sila natural numbers. We know naman kapag natural numbers, it starts with 1, 2, 3, 4, and so on. So disregard 0. This is a typographical error. So natural numbers, it starts with 1, 2, 3 up to infinity. And then we have whole numbers. Yung whole numbers, yun yung mag-start sa 0, 1, 2, and 3, and so on. Let's correct natin yung ano. Listen natin yung okay. So we have set of integers and we have set of positive integers. So remember, dinidenote natin yung positive integers, nilalagyan lang natin ng exponent na plus or superscript na plus sign. So ibig sabihin ng lahat ng positive integers. And then meron tayong set of real numbers. So lahat ng real numbers. And then also we have rational numbers. We're going to define rational numbers sa mga susunod na examples natin. So we have here set A, which is a null set. Again, when we say null set or empty set, ibig sabihin it is a set that contains what? No elements. So walang element na nandoon. And then also we have here set A that contains Z. So this is a set. And remember, Z is element of A, but Z is not equal to the set that has Z. Okay? Remember ha, yung element na Z ay hindi equal sa set na mayroong element na Z. So they are exactly different. So we have here set A. Set A na may lamang dalawang set. Set na mayroong B and C at set na mayroong C, X, and D. So yung set A natin dito sa third example ay set na may lamang dalawang set. And then we have here set A for the 40th example. So meron tayong set na may lamang set that contains x, y. So note that set xy is element of A, but xy is not equal to the set that has set xy. So yeah, I hope this is clear to you. So we have here set A that is equal to x such that x belongs to this function p of x. Okay, so this is set of all x such that p of x. So we have here 6 examples. So we have A is equal to x such that x is an element of natural number and this is and. So itong symbol na to, and yan. So that is a logical operation. So we have x is greater than 7. So ibig sabihin nun, it is a member of natural numbers so from 1, 2, 3, 4, 5, and so on. And it is greater than 7. So it will start sa 8, 9, 10, and so on. So yun. So we are now able to define the set of rational numbers. So when we say set of rational numbers, these are numbers in the form of A over B. So where A is an element of all integers and B is an element of positive integers. Or so we have here Q is equal to A over B, such that A is element of Z and B is element of Z and B is not equal to 0. Okay, correction here. We're going to correct this. And we're going to add here and B is element of Z or negative. Okay, kasi as you can see, ang kinonsider lang na value ng B dito is yung positive integers. Pero hindi niya sinama si negative integers kasi sinama natin. So dito naman sa pangalawa, so kasama yung lahat ng integers daw. So kasama na si positive and negative basta hindi mag-equal sa 0 yung B. So ayaw natin na mag-equal sa 0 yung B kasi it will result to undefined. So any number that is divided by 0 is undefined. And how about the set of real numbers? So we can denote the set of real number as R is equal to R such that R is a real number. So yun na yung pinaka-the best na pwede natin gawin for a real number sa set builder notation. So we have here subsets. So when we say subsets, so A is a subset of B. So A is a subset of B. So we're using this symbol, A subset of B. A subset of B if and only if every element of A is also an element of B. So we can completely formalize this. Ibig sabihin nun, if A is a subset of B, ibig sabihin nun, sa lahat ng X, for all X is element of A, then X is element of B. We have here example. So dapat daw lahat ng elements na A ay nasa B para masabi natin na si set A is a subset of B. So we have 3 and 9, or A contains 3 and 9, and we have B contains 5, 9, 1, and 3. So as you can see, yung 3 and 9 is makikita natin dito sa set B. That's why A is a subset of B. So we have here another example. We have A that contains 3 trees, and we have 9, and then also we have here B with 5, 9, 1, 3. Remember sa sets, wala tayong pakialam kung ilang beses mag-appear yung isang element. This is just considered 3 and 9. So we have 3 and 9 also here. So ibig sabihin, A is a subset of B. And we have here A is equal to or that contains 1, 2, and 3. And we have set B that contains 2, 3, and 4. So as you can see, on set B, there is no 1. So it is false. It means A is not a subset of B. So here are useful rules. So when we say if A is a subset of B and B is also a subset of A, ibig sabihin nun, the two sets are equal. And if we have A subset of B and we have B subset of C, this implies that A is also a subset of C. So as you can see on the diagram, so we have A is a subset of B kasi nasa loob ni B si A, and we have B is a subset of C. So as you can see, A is also a subset of C. So here's the Venn diagram with our universal set na naka-rectangle. So another rules. So the null set is a subset of A for any set. So lahat ng set natin, lahat sila subset si null set. And also, A is a subset of A for any set. So any set is a subset of itself. So proper subsets, when we say proper subset, we denote proper subset as yung parang ano, tawag ito, symbol ng subset pero wala na yung line sa baba. So A is a subset of B, or A is a proper subset of B if and only if lahat ng elements ni A ay inakay B, pero hindi equal si A sa B. The main reason kung bakit natanggal na yung line dito is that kapag sinabi natin proper subset, dapat hindi sila mag-equal. So, lahat ng subset ni A or lahat ng subset ni B is considered a proper subset except sa except sa null set and yung set itself. So yun. So if given a set, so kahit na anong set, lahat ng subset niya except si null set and yung buong set mismo are considered proper subsets. So si null set and yung set mismo are called improper subsets. So we have here cardinality of sets. So if a set S contains distinct element, where n is element of natural number, we call S as a finite set with cardinality n. So we have examples. Ibig sabihin lang ng cardinality again, this is the number of elements inside the set. So as you can see, we have set A here. We have Mercedes, BMW, and Porsche. So we have 1, 2, and 3. So the cardinality of A is 3. And we have here set B. So as you can see, we have set B. So we have elements 1, set 2, 3, set 4, 5, and 6. So we have 1, 2, 3, and 4. So the cardinality of B is 4. And we have set C. So as you can see, set C is equal to null set. We know naman na ang null set has a cardinality of 0. And we have B. B with that element X as element of natural number and such that X is less than or equal to 7,000. So this will start sa 1, 2, 3, 4 hanggang sa 7,000. So the cardinality of D is equal to 7,000. And we have the last example. So we have X is element of natural numbers such that X is less than or is greater than or equal to 7,000. So yung kanina, less than or equal to 7,000, that's why pababa. Dito naman, X is greater than or equal to 7,000. So this will start sa 7,000, 7,001, 7,002, to infinity. That's why E is infinite. Okay, so next, we have power set. So power set of A is denoted as P, open parenthesis A, and close parenthesis here. So you can read this as power set of A. So power set of A is equal to B such that B is a subset of A. So ibig sabihin lang ng power set, this is a set that contains all the subsets of A. So we have here examples. If we have set A, we will get this power set of this set. So susulat natin power set of A kasi A yung ating set, and then kukunin natin lahat ng subset dito. So we know naman na si null set is a subset ng lahat ng set. So null set at saka yung set mismo. So okay na yung null set tapos yung buong set mismo. So ililista na lang natin yung other subsets. So yung other subset niya, unahin natin yung tig-isang element muna. We have X, we have Y, we have Z. And then yung tig-dalawa, XY, XZ, and YZ. So huwag mong kakalimutan yung mga parentheses dyan kasi those are subsets. Kaya sila naka-enclose pa rin sa braces or braces. So power set of A is a set containing the following subsets. So now set with X, set with Y as its element, Z, XY, XZ, YZ, and the set itself, yung set A. So if you have set is equal to null set, so kukunin natin ang power set dito. So power set of A is equal to the set that contains null set. So remember na ang cardinality ng A dito sa last example natin is 0, and the cardinality of its power set is 1. So paano ba natin malalaman kung ilan yung members ng power set ng isang set? So una, we are going to check the cardinality. Kasi yung cardinality ng power set yung magsasabi kung ilan bang subset ang nandoon sa set na yun. And makukuha natin yun sa formula na to. So 2 raised to the cardinality of the set. So imagine each element. So kung makikita natin, so, kung ang kung mayroon tayong tatlong element dito. So we have element X, element Y, and element Z. So as you can see, meron tayong 8 combinations. XYZ, XYZ, yun yung ating mga combinations. So kapag tatlo ang elements, ibig sabihin nun, ang ating power set ay nag-expect ng walo na elements. So, as you can see dun sa ating example dito, so 3 yung cardinality ng A natin. So, 2 raised to, kung ilan yung cardinality ng A natin? So, ang cardinality mo is 3. So, 2 raised to 3 is equals to 8. Kasi, ang 2 raised to 3 ay 2 times 2 times 2. Okay? That is 8. Hindi yan 2 times 3. That is not 6. That is 8. So, 8. Ibig sabihin nun, we are expecting 8 subsets. So, what we have 1, 2, 3, 4, 5, 6, 7, 8. So, kapag 8 na yung naisulat ng subset, ibig sabihin nun, naisulat na lahat ng subsets mo A, and yun na yung power set. So, yun yung way natin para ma-verify kung na-lista ko natin lahat ng mga subsets ng A. So, we are going to check the cardinality of the power set. So, kapag apat ang, for example, we have set B. Kapag apat ang elements, 1, 2, 3, and 4. Okay, so we are expecting how many subsets? 2 raised to 4. And 2 raised to 4 is equal to 16. So, 16 na subsets ang nilista nyo sa power set. Kasi yung cardinality niya. So, okay na yan. So, we have here Cartesian product. Cartesian products, the ordered n-tuple, ace of 1, ace of 2, ace of 3, up to ace of n, is an ordered collection of objects. So, 2 ordered n-tuples, ace of 1 to ace of n, and b's of 1 to b's of n are equal if only if they contain exactly the same elements in the same order. So, in this Cartesian product, importante na yung order natin, yung arrangement natin. So, hindi natin pwede pagbalik na rin yung dalawang elements ng ating ordered n-tuple. So, Cartesian product is the Cartesian product of two sets is defined as A times B is a set that contains the following ordered pairs. So we have A and B, where A is element of A and B is element of B. So we have here example, set A contains XY and set B contains ABC. So unahin natin, so we have X, yun, and then yung first element din yun, A. So we have X ulit, tapos yung first element, B, X and B. Tapos yung X ulit, tapos yung C. And then next yung Y and A, and then Y and B, and then Y and C. So lahat yan are considered elements ng ating Cartesian product. So remember yung sinasabi kong order o yung arrangement is ito. So dapat hindi magbabaliktad si XA at XA or si XB. So kailangan XA sila pa rin. So, ganyan yung itsura dapat nila. Hindi pwedeng AX, hindi pwedeng BX. Kasi it is not the same. Pero kapag pinagbaliktad mo kunyari si XB ay nauna yung sinulat dito, pangalawa si XA, okay lang yun. Pero ang sinasabi kong importante ang order is yung ordered pair, yung pares na yun, nasa loob ng parenthesis. Dapat hindi nagbabaliktad yan. Next. We have here the Cartesian product of two sets defined as AXB or A times B. So we have here ordered pair AB, where A is element of set A and B is element of set B. So we have your example. So we have good, bad as our set A, and we have B with student and professor. For us to get the Cartesian product, so kukunin natin yung first element. A, good. Tapos yung first element ng B. So good and student. Next, yung first element with A, and then the second element with B, where we have good prof. Next, we have the second element ng A, which is bad, and then we have our first element ng B. We have bad and student, and then we have bad and we have prof. So, itong mga ordered pair na to are the elements of the Cartesian product of A and B. Remember, hindi pwede magbaliktad si good at student. So, dapat ganun yung itsura nila. So, next. We have B times A kapag baliktad naman. So, we have student good, prof good, student bad, and prof bad. So, as you can see, magkaiba ang output ng A times B sa B times A. Note that A times the null set is null, and we have null times A is also null. And for non-empty sets, A and B, A is not equal to B if and only if A times B is not equal to B times A. So we have here the cardinality of A times B is equal to the cardinality of A times the cardinality of B. And the Cartesian product of two or more sets is defined as ganun pa rin. So, A times A sub 1 times A sub 2 A sub n with the A sub 1, A sub 2, A sub n, where A sub I is element of A for I is greater than or equal to 1 but less than or equal to n. And we have set operations. We have union. So we have union set A with elements A and B, and we have B with elements B, C, and D. If we're going to get the union, we're just going to unite all the elements. We have A, B, C, and D. And for the intersection, so we're going to get the elements with, we are going to get the elements na nasa parehas na A and nasa B. So we have example, set A with A and B, and set B with B, C, and D. So we're going to look for elements na nasa parehas na set. So yun yung C, B. So ang ating intersection ng A and B is a set with element B. And we have two sets are called disjoint if their intersection is empty. So, kung wala silang intersection, or nakaset ng mga intersection, ibig sabihin, yung two sets na yun are disjoint. So, A intersection B is equal to null set. So, they are disjoint. And the difference between two sets is that A and B contains exactly those elements of A. A and not and B. So, lahat ng elements ni A, pero dapat wala kay B. So, as you can see, elements ni A is A and B, and for set B, yung elements ni I, B, C, and D. So, si A, B, yung elements ni A. At titignan mo yung elements ni B, kailangan yung element ni A is wala kay B. Since yung B ay na kay B, so we're going to cancel that. So, ang A minus B will be set with element A lang. Naalis na yung B kasi na kay B siya. Okay? Set operations, the complement. So, when we say complement, it is we're going to subtract the A doon sa ating universal set. So, lahat ng matitira sa universal set kapag minus natin yung set na kinukuhaan natin yung complement. So we have here, set U is equal to N, and B is equal to 250, 251, 252. So ang ating B complement, kung aalisin natin yung 250 hanggang sa infinity kung sa ating natural numbers, ang matitira will be 1, move the 0, this is incorrect. So B complement or B prime is equal to 1, 2 hanggang sa 249. So, set operations. So, makikita natin paano i-prove yung A union B intersection C is the same as A union B intersection with A union C. We have two methods in method 1. So, X is element of A union with B intersection C. And ibig sabihin nito, X is element of A union, and X is element of ito. So, yung union will be equivalent to 4. 4 yan. Remember, yung ganyan, yung B na nakabaliktad is N, and yung B will be 4. Remember, kapag OR is union, and kapag N is intersection. So, ito. X is element of A, or X is element of B, intersection C. And gagawin natin intersection. X is element of A, or X is element of B, and X is element of C. And then we're going to distribute yung X element of A. So distribute, so yung X is element of A, or X is element of B. So ito, punta dyan. Tapos ito ulit, punta dyan sa C. And X is element of A, or X is element of C. And then babalik na natin dyan sa union and intersection. So magiging X is element of A union B, and X is element of A union C. And we will have X is element of A union B intersection with A union C. So they are the same. Or we have method 2, or using the membership table or the truth table. So 1 means element of the set, and 0 means it's not an element of the set. So we have here the truth table. So we are going to discuss it on logic. So we have 0, 0, 0. So as you can see, yung ating third column and then ating fourth column are the same. So it's sabihin nun, they are equal. So we're going to discuss this sa part ng truth table, sa logic.